Hello, Andrea and Wilitsa. This is Francisco Labor from Genmoji. This is a short video to show you a little bit of the two-dimensional and three-dimensional design, the CAD design and the three-dimensional design of the array at Embody in Santurce. This is the CAD design. As you can see here, this basically shows you, number one, the obstacles, um, and which is the big building that you have in the south, which is about 15 stories. This is a little bit beyond the 200 feet range, but in comparison to your building, it's about 157 feet or so. Actually, about 147 feet. We have to take into account that just around, a little bit further down to the north, is 0 feet. Right around this area, you're around 60 feet above seawater, or sea level, I should say. Um, so this basically constitute, and as I'll show you in a bit, this constitute a big obstruction, particularly in the winter time, as the solstice, sun solstice, shines in a much further south um, range than in the summertime. But anyway, this is the irradiance factor. Basically, you see here, this basically what it tells you is how much energy each section of the building will actually create, somewhere around 1.2, 1,000 or 1,297 kilowatt hours per square meter per year here. And if we go further up here, as you'll see that that number increases. That's why, of course, the solar array is going to be to the north side of the building, where you have irradiance factors of 1,600 kilowatt hours per metric square meter per year. The design calls for an array of about 36 panels with microinverters or optimizers, I should say, to maximize the production of individual patches inside the array. And of course, you will see in a bit that that design will have to take into consideration the different obstacles that we have in the middle, particularly this obstacle that we're not showing here. And there's a good reason for that. If you don't mind, give me a second and I'll show you why I'm not showing that. So now I'm going to go into the three-dimensional. This is a three-dimensional look to your building, the obstacles around the building. As you can see, we've taken into consideration the trees around. We didn't do a design of the Colegio de Arquitectura right next door, as we thought that it was not going to have any type of impact on the irradiance factor. But of course, this big apartment complex that we have here, about 157 feet, 16 stories, it's a flat roof. As you can see, we have the direction of the sun, or the cycle of the sun on the daily basis. It goes from 6 in the morning, 8 a.m., 10 a.m., 12 p.m., 2 p.m., 4 p.m., and 6 p.m. Now here we can actually change solstices, analimas, which is basically the position of the sun in relation to the location, and our labels, and sun, of course. We can actually show where the sun is. And here we can actually change the month, the day, and the hour. So as you can see, we're actually showing here month 6, which is June. You're looking at perhaps when the sun is further north, and its trajectory between east and west. And during this time, as you can see, if I actually look into the day, from 6 a.m., I start moving the sun. Give me 1 second. Okay, 6 o'clock. That's 7 o'clock, 8 o'clock, 9 o'clock. Notice the shades. See, we have shades coming up here. And then once we're around 10 a.m., we have a lot of sun coming in. Right around 11, we're getting to the peak. 12 o'clock is pretty much peak. And as you can see here, the sun really is not going to be blocked by the building during this month of the year. So that's going to be the same case for uh, June, July, August, and a little bit into September. Um, as you can see here, the shading factor of the building happens to the east and not particularly to the north. So this sun, we will be able to actually, as you can see, look at where the sun is. The sun is actually going to follow this analemma, which is the northernmost analemma trajectory of the sun, which happens in the summer. As you can see here, the further south is the one that happens in the winter time. As you can imagine, this building would have a big impact on that. But during the summer, we're definitely going to be producing a lot of energy, which is actually going to be able to not just charge the batteries, but also um, it's going to it's going to allow for energy savings, significant energy savings on a monthly basis. So as you can see here, just around 6 o'clock, um, this is where basically it's not an issue of shading. As you can see, maybe by around 4 o'clock, we have a little bit of shading in this section here. Okay, but that's not an issue as our array is right here. All right, so if we look into something the complete opposite, month one, which is January, now this changes drastically. You can see here, first of all, at 7 o'clock, it's still very, very dark at that time of the year. 8 o'clock is when we start seeing some sun. 10 o'clock is when we actually start seeing some real production. And then just about 11 o'clock and 12 o'clock, that's when we have our peak. Now, if you look here, already at 12 o'clock, the sun being at 12 o'clock, remember the analemma, which is the position of the Earth in relation to north-south points, is further south. Therefore, the building becomes more of an obstacle. But once we're at 12 o'clock, we start seeing shadows. At 1 o'clock, you see how half of the building is shaded. At 2 o'clock, pretty much our whole building is shaded. So our production may actually go down in terms of irradiance, maybe 2/3. So it's a substantial decrease. And right after that, as you can see, the shade continues all the way down to the end of the day. So our, real production days at times during the winter time is between 10 o'clock and 1 p.m. At 1 p.m., we start seeing some shading into our system. Now, it's very important for you to see that our system, despite the fact that we have a big obstacle here, which we did not paint or design into the system. The reason why we did that is because we're raising the system very much like a carport type design. We're raising this system to be above 6 feet tall. Okay, so we can actually take it down to about 5. I believe it's 5. Let's see, it's fixed 6 feet. We can change that to 5 as our center obstacle or obstruction. It's about 4 feet. We can take it to 5 feet, and we can actually use part of the obstruction itself. Yeah, put it here. There we go. We can use part of the obstruction itself to as part of the support system for the array. Okay, so that's very, very very important factor here that we're actually raising the system so we can be above the obstruction, and that way we are not having to put maybe half of the system here, another half of the system here. It allows us to use much more space, be more efficient, and do it with a cost effectiveness that makes sense for everybody. So the different trees that you see around, they don't really become any factor. They're, of course, they need to be built into the design just to make sure that they don't have any type of issue. So this is, I just wanted to show you that these, if I want, for instance, if I change the month, February, I changed the month to March. As you can see here, it's a little bit different, right around 12 o'clock, maybe, we start seeing shading at 1, but 2 o'clock we still have, in the month of March, we still have a shading at 2 o'clock that is only compromising this part of the building, the southern part. Our array is still going, it still has lots of light. So it's maybe about 3 to 4 months that we're going to have a little bit of issue where we're going to be limited to maybe about 3 hours. The rest of the year, definitely will have more than 3 hours. The 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 expectations are that we would be somewhere around 4 to 5 hours. So 4.5 to 4.7, which actually makes it even better for us in terms of generation and the pricing that we can work on for you guys. All right. So this is what I wanted to convey. I will be sending you. You should have your proposal by the time you get this video. Um, if you have any questions or recommendations, please feel free to send it to me, and hopefully we'll get to do this for you in as little as possible. Thank you very much.